Code webinar series. Today we will be talking about application performance monitoring with Azure Application Insights, Azure Monitor, and Azure Log Analytics. My name is Victor Mushkatin. I'm CEO of Viacode. I was the founder and CTO of a company called Avicode, precursor to Viacode. Avicode was acquired by Microsoft in 2010, and its product, Avicode Intercept Studio, was used as a foundation for .NET and Java monitoring in System Center Operations Manager. As part of my Microsoft gig, I was driving System Center Ops Manager, and later we started a service called, now known as Azure Application Insights. Before we go into demo, couple housekeeping points. Webinar duration will be 60 minutes. All the content will be available to you later, to all attendees later. If you have any questions, please use Q&A tab in the lower left corner of your screen, and I'll do my best to answer them at the end of the session. You can follow us on Twitter. So let's begin. The seminar will be broken into two parts. First, we'll talk about core monitoring concepts in Azure. And then we'll do real-world examples and do demo. When customers move to Azure, they have lots of questions, and I group them into essentially three buckets of questions. First, who is responsible for what? What do I monitor as a customer of a cloud? What is Microsoft responsible for? Second set of questions is what I can play with. What are the core building blocks of Azure Monitoring? And the last, how I can put it all together. There seems to be lots of services. Sometimes it seems like they do the same thing. So what is the overall picture of Azure Monitoring? As part of this webinar, I'll try to answer on all of these questions. Before we start answering questions about monitoring, let me present you a rather radical view on Azure. I was trying to simplify the entire Azure infrastructure for the purpose of this webinar and broke it down into three buckets. First, we start with ARM. ARM, Azure Resource Manager, essentially is an asset management system. It's an orchestrator of all resources in Azure. So if you need to create resource, stop, start, delete, you do that through Azure Resource Manager, through ARM. So ARM knows about the entire Azure infrastructure. Then I broke all services into two pieces, into two buckets. First bucket, I call it compute. Essentially, any service that execute your application. It could be VM, it could be functions, app service, etc. And the importance of that is that there is a shared responsibility of that those services. Microsoft is responsible for running VM, but you're responsible for what's going on inside that VM. So it's very important for you to understand the boundaries of what Microsoft is responsible and Microsoft monitors versus what you're responsible and you're monitoring. And then the rest of the services. Those services that your application depends on, let's say storage, Event Hub, Redis Cache, etc. So those three buckets comprise the entire Azure ecosystem. And each piece of telemetry generates, each piece of infrastructure generates telemetry. Let's examine what telemetry is available. First of all, Microsoft itself monitors Azure as a distributed data center and reports its health through a service called Service Health. When you do any actions with your resources, all of those audit events, if you will, stored in a log called Activity Log. Every service in Azure reports its metrics and logs. And your application can report metrics and logs using Azure SDK. Now let's go a little bit deeper into every one of those. So this is Azure Service Health service that you use to see the health of Azure infrastructure, any kind of issues, understand scheduled maintenance events, and recommendation from Microsoft. And in this example, there is a warning to you as a customer that in a particular region, it was determined that there is a performance degradation, and your VMs might be affected. There's no definitive answer in this particular case that that you are affected, but based on the overall state of that data center in that region, for that particular service, it's been determined that your particular VMs might be affected. That's what you get out of Service Health service. As I mentioned, all your control actions done through ARM, and ARM reports all such activity into Azure Activity Log. In this case, what you see here, there was somebody deleted a database, and there is a record, and you can dive into JSON payload to understand actually what had happened at that time. So all your audit trail information is stored inside Azure Activity Log. The next bucket of logs is infrastructure logs. Many of you are familiar with, let's say, Windows event logs. You might be familiar with W3WC IIS logs. You've used Linux with syslog, etc. All these logs, all these infrastructure logs from every piece of infrastructure in Azure can be collected and centrally stored inside Log Analytics service. And you could use that service to correlate information and to dive deep into the data collected. The next piece of log I also single out, and it's application logs. In a way, it's similar to activity logs. It's a different beast. It's what Azure knows about the resource. That's your activity log. Application logs, it is what application knows about itself. Most likely you are using already some type of instrumentation using, let's say, iLogger interface with Serilog, or you use Log4net, nlog, and so forth. So you're familiar with the concept of tracing. You know that sometimes applications throw exceptions. So all that information can be collected and stored in application log. And the last piece of kind of building blocks is metrics. Every service expose its health through metrics as well. Not only logs, but metrics. For some people, there is a big difference between logs and metrics. For some people, it's such a subtle difference that they don't understand why there's a special case. Metrics is essentially a time series data that is usually used to generate alerts, plot nice charts, etc. You might be familiar with time series database like OpenTSDB. influx, etc. Same thing here, same concept. Now, at this point, we've talked about core building blocks, core telemetry types, if you will, building blocks for Azure Monitoring. You have service health that provides the health of the entire Azure distributed data center infrastructure. You have metrics and logs. The entry point to Azure Monitoring is a service called Azure Monitor. And if you go to Azure Portal and select Azure Monitor, most likely you will see some picture, something like this on your left-hand side. You would see familiar logs, activity logs, metrics, and then at the bottom you would see insights or solutions like application insights, network watcher, and so forth. A lot of customers asking questions, so how it's all put together? It seems there's a lot of pieces of this puzzle, and it's hard for me to wrap around my head. Let me simplify this picture for you. And at the core, at the base of the monitoring, there are two services, metric experience and log analytic experience. That's the foundation for your monitoring. On top of that, you have building blocks of any type of monitoring, which is alerts. You can generate an alert on a metric or log. You can create monitoring dashboards based on that information, metrics or log information. And then, as I mentioned before, Microsoft itself provides the health state information through a service called Service Health. On top of that core infrastructure, there are domain-specific insight and solutions. For example, Security Center is everything about security. Application Insights is everything about application. Network Watcher is all about network. And because those solutions understand telemetry types, they provide unique, tailored experience on top of those of such telemetry. Because those solutions see that telemetry not as a raw log entries or raw metrics. They understand what those log entries actually means and can infer certain insights, certain information. For example, you can see a network diagram based on logs. You can see application topology based on logs, and so forth. So this is three layers, if you will, of Azure monitoring: metrics, logs, core monitoring primitives, alerts, dashboard, service health, and then number of insights and solutions. Still, a lot of customers asking, why do I need all these solutions? And do I really need to install all of them? The short answer is yes. Let me highlight the need to use various solutions based on such a simple example of CPU. And for the demo purposes for this presentation, let's pick on VM, an application running inside a VM. First of all, when ARM manages your VM, it knows about VM CPUs. So this is kind of coarse-grained view on CPU. And if VM is completely hosted, like CPU 100% pegged and turns into a black hole, nothing coming out and nothing comes in, ARM can tell you that, hey, this CPU is not functioning and it's 100% utilized. So it's useful from that perspective, that ARM always know what's going on with the container. Now, CPU on the VM, and you are familiar with diagnostic settings. So if you go to VM and you configure diagnostic settings, you are collecting, so you can collect conditional metrics. So collecting CPU from the VM provides you finer grain metric about your VM, because you are collecting that metric from inside the container boundaries. Here we go. You already have 2 CPUs. But we don't stop there. If you're running, let's say, web application, every time when you recycle the process and uppull starts, W3WC will have a new PID, new process ID. And if you want to know exactly how much your application consumes, you need to collect CPU for that particular process. And that's where you get another CPU. You get application CPU collected from within inside the application. By implementing additional solutions, you are collecting more information and creating a deeper understanding, going deeper into the stack of your infrastructure. Certainly, if you want to collect just power and ping, ARM would be good enough for you. And in many cases, if you need to just monitor up or down state, that would be reasonable, quote unquote. But if you need to be able to diagnose and provide some type of root cause analysis, chances are you need to implement additional solutions and insights. Another important point that we talk to customers when we do implementation is correlation. And for the purpose of the slides, I will use application telemetry to highlight the point of correlation. Later in the demo, I'll show how to correlate logs, metrics, and end-to-end transactions. The correlation is very important when you collect all this data and trying to rationalize it. Consider the application as a piece of code that's running in some type of process. It accepts requests. It calls some other applications or services, let's say SQL or storage. It sometimes throws exceptions. This application is a single unit of deployment, management, and support. And it's running usually within the boundary of a process. Application Insights will automatically collect for you all this incoming request, outgoing dependency calls, and all the exceptions. Moreover, if you want to expose, let's say, some type of metrics, you can use Application Insights SDK to expose that. If you want to expose some type of usage events, there is a telemetry type for that. And if you use, let's say, Winston logging or logback in Java, you could channel all those logs to Application Insights in a form of a trace. And the beauty is that Application Insights will do correlation between all incoming requests and all outgoing telemetry or all outgoing traces. So you would know within the boundary of request what traces and, let's say, SQL calls have happened as part of that request. And that's a correlation within single component. But it gets more complicated if you look at your application topology, where you have multiple components talking to each other, talking to some other pieces of infrastructure. Understanding the correlation and how correlation works helps you improve your triage experience to understand which service is at fault when you have a problem, as well as your diagnostic experience. And I'll touch base on correlation a little later. Now let's talk about our customer. We had a customer who approached us and ask us to help them implement some monitoring solution. If you've attended our prior webinar on ARM, we use the same customer to highlight deployment automation. Here I'll be talking about that very customer from the monitoring perspective. And customer had a very typical, very simple architecture. Its service consists of Azure App Service as a front end, plus a couple back-end services, SQL database and analysis services. What customer did is customer installed everything that Microsoft prescribed. Azure App Insights, SQL Solution, and Azure Monitor. And then they had couple big questions. First questions that we will be talking today during webinar, what to do with all of that? We are collecting all of this, and we're not really sure what to do with all this telemetry. And months later, they had another question. Why am I paying for all of this? Can I just trim it down somehow so my bill is not that big? And that's the subject for our upcoming webinar. But today we will focus on the telemetry collection. Together with customer, we identify the goal of this project. First, we said that we need to automate detection of SLA impacting incidents. And industry standard is to be able to detect over 80% of all your LSIs, live-site incidents, automatically. Second, customer was very keen on improving their processes around mean time to resolve. It included kind of ITSM process, service management process. It included collecting right actionable information. So it was a set of issues that we had to address. And the last question is, as any customer has, is the cost efficiency. That particular customer has a especially sensitive cost question because we help them first transition from on-prem, lift and shift, to the cloud, including monitoring infrastructure. So we basically took System Center that was running on, I don't know, X number of VMs up into the cloud. And this was the second phase of that project. Transition that monitoring into cloud native. And that was an interesting challenge for us where we had to explain to the customer the benefit of moving from System Center in the cloud, running inside VMs, into cloud native monitoring. But we'll talk about that later. And today, we'll talk about essentially a DevOps lifecycle. You guys are all familiar with this infinity loop, right? Devs on the left, ops on the right. Today, we will focus on operate phase. And you can look at this operate phase from the perspective of detect, triage, and diagnose. Detect is ability to automatically or manually understand that, hey, there is a problem in a system that I need to address. And once you detected that there is a problem, you need to notify the first level of support. As part of a triage process, you're answering basically two questions. First of all, what's the impact? How many users affected? Because that's what defines severity of the incident. And second question is, who's at fault? Who should I escalate this problem to? So ability to understand how this all infrastructure put together is very important for this stage, this phase. And once you determine particular service that is at fault, you need to be able to have all the tools and all the information to diagnose the problem, to understand RCA, to provide a root cause analysis. So let me do the demo of this process, detect, triage, and diagnose process. For the demo purposes, I'm going to use demo application. We couldn't use customer application for obvious reasons, but we picked application that is very similar to what customer has. This is a Vicode MPWiki site that System Center experts use to get updates on most recent management pack from Microsoft and understand the management pack structure. It provides a nice visual GUI for management pack developers. And as you can see right now, it's working. If I click, you see it renders. What I'm going to do, I'm going to break it. So pretty soon it will stop working. Okay, it stopped working. So now imagine I'm an ops guy, DevOps guy. I haven't seen that yellow screen of death, and I would be waiting for a system to notify me that something is not working. While the system is going through its motions of detecting that it's in fact a SLA impacting incident, let me talk a little bit about the infrastructure and topology of the application that we're looking at. From the infrastructure standpoint, all resources are broken down into two resource groups, MPWiki and MPWiki Telemetry. MPWiki group, it contains all actual resources. For example, cloud service, storage, SQL. Typically, developers and product owners do not have access to this resource groups. They should not be able to start these resources. It's all done, first of all, through automation, and second of all, only by a limited set of people, like ops folks, DevOps folks. So that was MPWiki group. MPWiki Telemetry group, on another hand, contains, let me show all hidden types, all the artifacts that are related to telemetry about your infrastructure. That's where you can see, let's say, log analytic workspace. You see application insights, your alerts, your dashboards. And usually devs and ops folks have access to this group, this resource group, so they can tailor monitoring to their liking. So that's how infra looks. We have resources broken down into two groups, telemetry and actual resources. Now let's take a look at the topology. Topology of this particular application, you have a web role, you have a worker role, so you can see it. You have a SQL server, you have storage account, you have a browser component, and browser relies on a number of external resources. It talks to Mixpanel, it talks to Google Analytics and OpenSite. Little plug, we will be talking about usage, monitoring, and comparison between Mixpanel, application size, and Google Analytics in upcoming webinars. So what you see here is essentially application topology that consists of dependencies and a couple compute services. In addition to that, what you see here is my demo monitoring dashboards. And at the top, you see my, if you will, detect phase. So first of all, the Azure service health. And as you can see, everything is healthy. All data centers are healthy. So I'm good. Then you see 3 blocks of alerts. You see availability. That's synthetic availability. What I configured transactions that are executed on a time interval going against my endpoint. And every time when that transaction is failing, it indicates a particular, it indicates that something is wrong with your application. And if number of those failures exceeding certain threshold, you might get an alert. In addition to synthetic alerts, I'm monitoring real user transactions, and I configured a number of alerts based on real user transaction metrics. So I'm augmenting my synthetics with real user monitoring and configured real user alerts. In addition to that, I know that for my application, when one of these dependency goes down, blob or SQL, it's bad. So what I did, I elevated that monitoring to my main dashboard. So my triage process will be simplified. So if I see any kind of alerts on blob or SQL, I know that, hey, the problem is there. So now, hopefully, let me refresh the dashboard. And see if I get any kind of notification. And here we go. So I got as you can see, I got the alert. So I have a problem. And I don't know if you can see it, like you start seeing this red dots. This is my availability test summary, and I start seeing this red dots indicating that, hey, something's wrong. But let's go with the flow. I'm an admin. I don't look at this dashboards every minute. Instead, I have my phone that I sleep with, and I got this buzz. I woke up in the middle of the night, and I got this email. And I know it's not good when I'm getting some email from monitoring agent. So what I'm doing is I'm going to that email that I just received, and it looks like, well, before I go there, it looks like I have my MP-Wiki availability low. My target is 95%, and the current value is 92.3. That's not good. So I go to my notification emails, and what you see in front of you is Azure DevOps Services. That's what we implemented for demo purposes to highlight the ITSM integration. In your organization, you might use ServiceNow or whatever system you use, and you can integrate with those systems using various out-of-the-box integration or webhooks. So here we have Azure DevOps Services integrating with Azure Monitoring, and I received this notification. So what I need to do, I need to essentially understand what the real severity of this and who to call. And in order to do that, I'm going to triage it by clicking on availability degradation. And as you can see, I'm opening up another tab here and diving into my availability test summary. Let me zoom into the last 30 minutes. And sure enough, you see that it was fine, all green, all good, and suddenly it started failing, right? So let me click on one of those red dots. Whoa, I see lots of information, and I've heard from customers that they get overwhelmed with amount of information here. Let me demystify what you see. This is called end-to-end transaction monitoring. And in this particular case, there was a multi-step web test. For folks familiar with Visual Studio, that's a Visual Studio multi-step web test that has been executed in Japan East. One of the steps in that multi-step web test was a call to our service. As part of execution of that service, there was a call to SQL. And as part of that calls to SQL, there was an exception. And as you can see, essentially every step of my multi-step transaction is failing with SQL. So at this point, I know that the problem is most likely with my SQL server. I can go and examine my my failure. And for the demo purposes, essentially what I did, we changed the password for a user. And sure enough, application started failing. And this is an important point here. Your infrastructure is absolutely healthy. SQL is up. Your cloud service is up. Yet application is misconfigured and it's failing. So that's why it's very important to combine both infrastructure and application monitoring into kind of holistic view. So what you see here is something's wrong with SQL. Let's say this problem is not as obvious as this one. Your next step is to escalate this problem to a DBA or to SQL admin. Now, SQL admin might use various tools of their likings, and for the demo purposes, we prepared a specific dashboard for SQL diagnostics. What you see here is not really a dashboard in Azure speak. It's called a workbook. But for all intent and purposes, for this presentation, let's call it a dashboard. And what we did here, we did implement a correlation between requests, between end-to-end transactions, all activity logs about SQL dependency that is part of that end-to-end transactions. That's what ARM knows about that particular SQL instance. All SQL audit events, this is essentially information from the SQL itself, what SQL Azure knows about itself, and GTU consumption and metric on one screen. This is a great example of yet another correlation. Before we were talking about application end-to-end transaction correlation. This is an example of correlating various pieces of telemetry together in one screen. Here you have application telemetry, you have ARM telemetry, you have resource telemetry, and logs and metrics all on one screen, correlated. And you as a customer, you can configure these dashboards for most typical LSI situations. So from our experience, what we've seen customers do, as part of their DevOps lifecycle, they codify the knowledge about LSI, lifecycle incidents, in a form of alerts and a dashboards. So next time similar situation happen, they will have automatic detection for that situation, and they will have a starting point, some kind of dashboard for troubleshooting that particular problem. And that's what you have here. Now let me go back to my presentation and let's summarize what you've seen. Let's start with DevOps Detect, Triage, Diagnose. It's real. We have customers who did achieve 80% automatic detection and significantly improve mean time to resolution, KPI. Typically, we recommend customers, as when we're doing customer engagement, we start with assessment, and the outcome is this, as a first step, we automate detection using alerts on top of synthetic and real user transaction, as well as we identify key resources and we monitor those key resources. So we kind of cover our bases. And another very important step is integrate with the processes. Processes are very hard to establish and even harder to change because it's part of the culture. So we work with customers to integrate as much as possible all these monitoring, telemetry, monitoring concepts into their existing processes, into their existing support infrastructure, and help implement monitoring dashboards as part of that process. So our focus as a company to help customers to transition to DevOps, to cloud, and you can break down our services into automation, where we help customers to transition their existing processes to infrastructure as code and CI/CD for devs. We specialize in IT management. We help customers to implement monitoring, rationalize cost, improve security. And we help dev team to transition to modern cloud infrastructure, modern cloud services like containerization. We help customers to dev teams to instrument application to collect usage so they better understand what's going on with their users. If you need any of those services, please don't hesitate to reach out to us. We're interested in DevOps, and we would love to hear your story. As a matter of fact, if you attend Ignite, come to Microsoft booth. We will be working there. Talk to our experts, Alex and Roman. Roman won't look like this. He will have way more hair and on top and no hair at the bottom of his face. Please talk to our guys. We would be very interested to learn your story, how you overcome challenges, cultural challenges with DevOps, and what challenges you have specifically with Azure Monitoring, implementing Azure Monitoring for your organization. So at this point, we have about 10 minutes for Q&A. So guys, do you have any questions? I have a couple questions. First is what is a normal size of the telemetry? That's an interesting question, normal size of the telemetry. As a rule of thumb, Microsoft talks about 1 to 3 gig per VM per month. In hard numbers speak, it's about $2.3 per gig. So you look into $2 to $6, $7 per month per VM for bare bone VM telemetry. Let's say events, perf, and perf counters. With application telemetry, it's a little bit trickier, and maybe it's easier to look into application itself. This particular application, let me see, telemetry is really dependent on how much data you're collecting. And in Up Inside, there is a special analysis prepared for you, the breakdown on the telemetry. So you can analyze how much dependencies you're collecting, how much traces, requests, and so forth. There will be a separate webinar when we will be talking about optimizing cost, and part of that webinar we will talk about optimizing Up Inside data collection to lower the overall cost. And that's part of a big part of what we do for customers, because it looks like cost is a very sensitive issue, and predictability of Azure spend is very important. How long back you can go and view monitoring data? Let's say that in general you can look back to 90 days of telemetry data. However, if you want, there is a way to set telemetry aside and dump it into storage account. So you can analyze it later, or dump it into data lake for subsequent analysis, for storage. I've heard those kind of requirements from customers who want to implement some type of auditing processes where they need 180, 360 days of data. And storage doesn't cost much, so typically that's good enough. And that's a very important point, that the data that you use for monitoring should be readily available, and you typically need it for no more than, let's say, 7 days, 2 weeks. Data that you need for trending for analysis, I would agree that you might need for a year. You have ability to export data on a side. And since we're here, you can click on continuous export and configure your data export elsewhere. What is the typical price of monitoring solutions? As I mentioned, it really depends. If you're talking about basic monitoring, and by now you know the basic monitoring is essentially your kind of ARM type of monitoring, which is free. Basic monitoring for VM is essentially what agent from the VM collects, and by default it collects events and limited set of perf counters. It would not cost much. It would cost, let's say, $7 per month. However, we had a customer who was collecting 8,000 performance counters. 8,000 performance counters. In contrast to 15 performance counters out of the box, right? So, and for that customer, it was a typical monitoring. So what I would recommend for you guys to look at resource cost. So as I went to resource group and I click on resource cost, better probably go to because telemetry doesn't cost much. This resource cost for the group. And that's where you can kind of look at your spend on all your telemetry as part of the group. So I know in this particular case that on $44.61 that I have for my demo, that I spend on my demo, my telemetry cost is 70 cents. So it's a fraction of a percent. Well, it's a little bit more than a percent. Hopefully that answers the question. Any other questions? There is a question, the Robert asked TIA. I'm not really familiar with that abbreviation. If you could elaborate a little bit on what TIA means, I would be able to provide some answer. Any? Okay. So it looks like there are no more questions. I want to thank you all for attending our webinar. Please stay tuned. There will be more webinars available in the future. Upcoming webinar on usage, upcoming webinar on cost management. And thank you for joining me during this webinar. Have a good day.